All right, in section 11.5 we talk about something called elasticity, and we also talk about how adding a tax will change the supply and demand situation as well as the tax revenue. So when we talk about elasticity, we know from the law of demand that consumers will respond to changes in prices. If prices increase, the quantity demanded is decreased. Makes sense, because if the price goes up, fewer people are going to buy the product. But the degree of responsiveness to the consumers to price change will vary widely for different products. For example, a price increase in insulin will not greatly decrease the demand for it by diabetics because they need the medicine no matter what the price. But a price increase in clothes may cause consumers to buy less and wear their old clothes longer. When the response to price change is considerable, we say that the demand is elastic. When price changes cause relatively small changes in demand for a product, we say the demand is inelastic. And so they measure elasticity in this form. You got P equals some function in terms of Q, and that's your demand function, where P is your price and Q is your number of units or quantity. Then the price QP, remember Q, quantity, always comes first in this chapter, well generally in all chapters. Your number or quantity is first and your price or dollar amount is always second. So the elasticity of demand is used with this unusual Greek letter, which I'm not sure what it is, but it's N, equals negative P over Q times the derivative of Q with respect to P, and then you plug in Q and P into these items and you get your answer. Now example 1, they say find the elasticity of demand function P plus find the elasticity of the demand function P plus 5Q equals 100 when the price is 40, 60, and 50. So the first thing you have to do is solve the demand function for Q. So you got to bring P over here and divide by 5. Now you take the derivative with respect to P, just like you would if this was an X. So you get Q prime or dQ dP. You get 20 goes away to 0, and this just becomes negative 1/5. So now this is your elasticity of demand function equation. You'll always be using this no matter what. This part doesn't change. What changes is the function and its values that you plug into the function. So our dP dQ is negative 1/5 here. We plug that in. And if you multiply that out, you get P over 5Q. Now, you just have to plug in your P and your Q into this and find your elasticity. Now, if they give you price, you can find the quantity based on this equation. If they give you price, you plug in this case, 40 there, 20 minus 1/5 times 40, and that gives you 12. So you know that the quantity is 12 and the price is 40, so 1240 is what you're going to plug in. And again, the first one is quantity, that's where the Q goes, and the 40 is your price, and that's where the P goes. It goes where the P goes. So now you just multiply that across and simplify. Now if the elasticity of demand is less than 1, then we say it's inelastic. Now if you take the same situation and you find out what the quantity is for this price, you get 8. Plug all those things in and simplify, you get something greater than 1, so that means it's elastic. And then if you let P equal 50 and plug that in to figure out what Q is, which is 10, so now you got 1050 to plug into this thing and you simplify it and you get 1. Well, that means that you have what's called unitary elasticity, or unitary elastic. This is your best situation. This is where your revenue will be maximized. So note that in example 1, the demand equation was this. So the demand curve is actually a straight line with the slope equaling negative 5. But the elasticity was 2/3 for this situation, 3/2 for that one, and 1 for this one. So this illustrates the elasticity of demand. Here is where your elasticity was 1. Here's where it's less than 1. Here's where it's greater than 1. So the elasticity of demand may be different at different points on your demand curve. Even though the slope of the demand curve is constant, your elasticity is going to change. Right? This example shows that the elasticity of demand is more than just the slope of the demand curve, which is the rate at which demand is changing. Recall that elasticity measures the consumer's degree of responsiveness to a price change. So here's how the elasticity works. If the elasticity is greater than 1, the demand is elastic, and the percentage change in demand, percent decrease in demand, is greater than the corresponding percent increase in price. And if it's inelastic, the percentage decrease in demand is less than the corresponding percent increase in price. And then if n equals 1, the demand is unitary elastic and the percent decrease in demand is approximately equal to the corresponding percent increase in price. So example 2, they say find the elasticity of demand for this when P equals this and Q equals that. So I rewrote this with a negative exponent, so when I took the derivative it would be easier to do. And you get negative 100 P to the negative 2, which is negative 100 over P squared. So now you take the same equation as always, and you're going to plug in that negative 100 over P squared there. And we're going to use the Q is 9 and P is 10 into this guy, and we plug all those numbers in, and we get 10 over 9, which is greater than 1. That means it's elastic. Example 3, they give you the demand function here, but remember you got to solve for Q with your demand function. So we solve this for Q, then we take the derivative. When we take the derivative of a constant, we get nothing. When we take the derivative of that, we just get minus 2/3. So that's our Q prime. So then again, we plug that in right here, and here's our Q and our P, and we plug in all those numbers and simplify, and it's less than 1. That means this is inelastic. All right. Example 4. P times Q equals 81, and P equals 3. So you got to solve this for Q. So you divide both sides by P, and I rewrote it this way so it's easier to take the derivative, and we get negative 81 P to the negative 2, or negative 81 over P squared. And that's what we plug into here. We still have our negative P over Q. We still have our Q and P. Now how did I find Q is 27? Well, you plug in the one number you know, which is 3. 3Q equals 81, so divide by 3 and you get Q equals 27. So you plug in 3 for P, 27 for Q, and 3 for P there. Multiply it out and you get 1. So this one is unitary elastic. Number 5, they give you this demand here. And so you got to solve that for Q. So you got to bring the P over here and you got to divide by P to get Q all by itself. And I wrote it this way to make it easier to take the derivative. When I did, I get this and I simplify it there. So now that answer goes right there as always. And they gave us Q is 99 and P is 50. We didn't have to calculate those. So we plug in all the numbers we know and we simplify it, and it's slightly greater than 1, which means it is elastic. So like I said, if something is elastic, where your elasticity of demand is greater than 1, it means if the price increases, the revenue will decrease. Or if the price decreases, the revenue will increase. Makes sense. Inelastic is where if the price increases, the revenue increases, meaning that the price of the object doesn't matter. People are going to buy it anyway. And if the price decreases, revenue decreases. Very unusual. Unitary elasticity, it means that an increase or decrease in price will not change the revenue. Hence, the revenue is optimized at that point. All right. Taxation in a competitive market. Many taxes imposed by governments are hidden. That is, the tax is levied on goods produced and producers must pay that tax. Of course, the tax becomes a cost to the producers and they pass that cost on to the consumer in the form of higher prices for goods. Suppose the government imposes a tax of $T on each unit produced and sold by its producers. If we are in pure competition in which the consumer's demand depends only on the price, the demand function will not change. That's important. Your demand function is going to be the same no matter what the tax is. The part that changes is the supply function. The tax will change the supply function. Of course, because at that level of output Q, the firm will want to charge a price of P plus T per unit, where P is the original price and T is the tax on the unit. That's how they pass it on to the consumer. They add the tax to the price of the object. And when you do that, you're going to run into some problems. All right, so the graph of the market demand function, the original market supply function, and the market supply function after tax are shown. So here's your demand function. Here's your original supply function, but when you add the tax, your new supply function is this. Now because the tax added to each item is a constant, the graph of the new supply function is T units above the original one. So each point here is hiked up by T units. All right, so P equals the original supply plus Q. Note, after taxes are imposed, the consumers simply must pay more for the product. Because taxation does not change the demand curve, the quantity purchased at market equilibrium will be less, meaning they're going to sell fewer of them because they're charging more. Thus, governments planning taxes should recognize that they will not collect taxes on the original quantity. They will collect on the new quantity. Thus, a large tax on an item may reduce the quantity demanded, so much that very little revenue results from the tax. All right. In 1991, the government passed what was called a luxury tax on airplanes, boats, and cars that were very expensive. And they expected to collect around $6 million in revenue from those taxes. Well, what happened was the tax was such a high tax on the items that they only collected 53,000 instead of 6 million, and many different boating companies and airplane companies went out of business because of that, and they repealed the tax 2 years later in 1993. What happens here is if you have your original price here, the demand is here, this is your quantity that you will be selling. But now look, if you hike the price up with the new intersection there, now you have a lot less quantity that you're actually selling, and thus if you're selling fewer items, you're getting less in tax revenue. Alright, so how do you calculate the tax per item and the quantity that you will be selling, as well as the total tax revenue from that tax? Well, you write the supply function after taxation, so you add T to your supply function. You have to solve it for P first, okay? Then you set the demand and the new supply function equal to each other. So here's your demand, and here's your supply, and you take that supply and you add T, and then you set these two equal to each other. Okay? Then you solve it for T. You bring everything over to one side except for T, and you got this guy. Now, what is your total tax revenue function? It's just T times Q. So you take everything here and multiply it times Q. So instead of 400, you got 400Q. Instead of 4/3 Q, you got 4/3 Q squared. So now you take the derivative with respect to Q, and you get 400, and you get 8/3 Q. You set that equal to 0, and solve it for Q. So 0 equals 400 minus 8/3 Q. If you add 8/3 Q to both sides and multiply by 3/8, you end up getting Q equals 150. This is the quantity that should maximize your tax revenue. And you can use the second derivative to verify that this is a maximum. So you take the derivative of the first derivative and you get negative 8/3. That means your second derivative is always negative. And since your second derivative is negative, that means the number that you plug into it, 150, is going to give you a maximum. So now if you want to find the tax that will maximize your revenue, you go back to where you solve for T. In step 2, part 2. 400 minus 4/3 Q equals T, where Q is 150. So 400 minus 4/3, 150. That tells you your tax per item is $200. And to find the total tax revenue, it's just simply the tax per item times the number of items. So $200 times 150 items, that gives you $30,000 in tax. Example 6, same idea. You take your supply function and add T. Then you set your demand equal to that new supply function. And you solve it for T. Then you multiply everything by Q. You take the derivative, set it equal to 0 and solve. And you can't have a negative quantity, so that one's out. So quantity of 10 is your only critical value there. If you check your second derivative and plug that number into it, if you get a negative, that means your quantity is a maximum, which it is. So what is the quantity that will maximize your tax is quantity of 10. And if you go back here to t, whereas t equals this guy here, you plug 10 in for Q here, and you'll get what the price is. If you go back to step 2, you plug 10 in for Q here, multiply it out, and you get this. And this is the tax per item that you should charge. And so, what's the total revenue? It's simply the tax per item times the number of items. And there you go. So let's look at some questions that are similar to your WebAssign questions. The first one says, find the elasticity of demand and how will the price increase affect total revenue. So you have to solve your demand function for Q, and then you take the derivative, and you plug that into your formula, and you use the numbers they give you, and you get 1. That means unitary elasticity. It means thus an increase or decrease in price will not change the revenue. The revenue is optimized, and that is no change in revenue. All right, number 3, you take your demand and you solve it for Q. And since they give you P is 6, you can plug in 6 here and you can figure out what Q is. We figured out Q is 1. So you take the derivative and you get this guy here, and that's what you plug into this. We actually plug it in there. And now you use 1 and 6 for Q and P. Simplify it and you get 84. Since that's greater than 1, your demand is elastic, which means if price increases, your revenue decreases. So the revenue will decrease. Number 7, they give you this guy here and you have to solve it for Q. Alright, now you have to take the derivative of that, and that's the quotient rule. It's a bit complicated. Simplifies down to here. Now that's what you're going to plug in right there, and you're going to use these two values here. Now notice they only give you P is 401. Well, how did I find Q is 99? Well, you plug in 401 here and simplify it, and you get Q is 99. So once you get Q and P, you plug them into this guy here and simplify, and you get a number less than 1, which means your demand is inelastic. If the price is increased, the revenue will increase. Revenue will increase. This is typically when there's a object that people are going to buy even if the price goes up. Number 8, you have to solve this one for Q. Got to do a bit of work there. And once you know P is 39, which they tell you, you can plug in 39 in there and you find Q is 624. So now you take the derivative of that, and it takes a bit of work to do it, and simplify it down, you get to here. That's what you're going to plug in right there, which we do. And then you use Q is 624 and P is 39, and you multiply it out and you get something greater than 1, which means elastic. So if the price is increased, the revenue will decrease. And this means the revenue will decrease. Alright, so now this one's talking about the this is not talking about elasticity anymore. These next few questions are talking about the taxes. So you take your supply function and you add T, and you set it equal to the demand function, and you solve it for T. And then your total tax function is T times Q. So this is what T equals, multiply it times Q, and you get that. Take the derivative, set it equal to 0, and solve, and you get Q is 4. When you take the second derivative, you just get negative 6, which is less than 0, which means that your Q equals 4 will give a maximum. And if you want to know what the tax is, you plug it into T equals whatever T equals here. And that gives you a tax of $12 per item. And that will maximize your revenue. And what is your total tax revenue? It's the tax times the quantity. So 12 times 4, or $48. 17, you got supply equals this, and you add T to it, and then you set it equal to demand, and solve for T. And now you find capital T by just multiplying your T here by Q, and you get this guy. When you take the derivative, you get that, set it equal to 0 and solve, you get 140. Now when you check the second derivative of this is just negative 5, which is less than 0, which means that your critical value will give you a maximum. Now how do you find what your tax is? You plug it into where T equals, and you get a tax of $350 per item. So you're charging $350 per item in tax, and your total tax revenue is your tax times the quantity. So 350 times 140, or $49,000 in total tax revenue. This one, your supply is this guy here, and you add T to it. Your demand, you have to solve it for P first, is this guy, and now you set these two equal to each other and solve for T. You get this guy here. And now capital T is just multiplying each one of these by Q. It basically hikes it up to a cubic from a quadratic. When you take the derivative, you now get a quadratic, and you set it equal to 0. And there's no nice way to factor this, so you got to do the quadratic formula, which is nasty with decimals, but you get two answers, a negative 167 or a positive 82.7. And you can't have a negative quantity, so we're going with 82.7. And if you take the second derivative of this, you get this here, and if you plug in your 82.7 into that, you get a number that is negative. Remember, if the second derivative gives you a negative answer, that negative number, that means this number you plugged in is going to give you a maximum. Alright, so you plug that Q into the T equation, and you get a tax per item of $483.17. And if you multiply that times your quantity, which is around 83, you get $40,103.11.